7.1, solve linear systems by graphing. So obviously you had a graphing worksheet that you did yesterday during your snow day, so that way you could kind of get ready for this section. Overall, looking at tests, we are doing okay with graphing. The second or the last question on the test, a lot of people graphed incorrectly because it had a negative slope and it was graphed with a positive slope. Anyways, so we do need to make sure we watch that, because if you graph these backwards then or incorrectly, you're going to get the wrong answer. So system of linear equations. Why is this line not going away? There we go. So 2 or more linear equations in the same variable.
Is this going to be easy or is it going to be hard?
I think this is the hardest form of this because people struggle to graph. And sometimes the lines don't intersect nicely. Now, pretty much in this book they do, but in like the Algebra 2 book, they are not always kind in the problems that they give you. So, for example, this is just what a system looks like. We might have something like 3x plus 2y equals 8 and x minus y equals negative 2. So that would be a system of equations. And ultimately, we're going to have 3 different methods that you can use to solve these. So we're learning one of them today, one of them tomorrow, and then most likely, if all goes as planned, one of them on Thursday. And then we'll have a quiz after that. So.
Why don't we have no quizzes for the rest of the year?
Yeah, that's not going to go well.
Maybe just give us like A's for each one.
So a solution of a system of linear equations is an ordered pair that satisfies the equation in each system. So our answers are always going to be in the form x comma y. They're a point on the graph. We have consistent independent systems which is a linear system with exactly one solution. And you're probably like, when can a graph ever cross more than one time? Well, we do have options where sometimes if the lines are parallel, they don't cross, which is a no solution, or if the lines are the exact same line, then they would be infinitely many solutions. So anyways, just be aware of that we do have these other options as well. But for right now, we're just focusing on this consistent independent system where there is one solution. You don't have a game though.
I know. I actually have you. Me too. I like talking to Abby.
Steps to graph a system of equations. First, we're going to graph both equations on the same coordinate plane. get y by itself before graphing, aka put it in slope-intercept form. Which is y equals mx plus b. And then we're going to estimate the point of intersection. So if my two lines cross, that's my point of intersection right there in the middle. So that's the point that I'm estimating. And then 3, we're going to check the coordinate by plugging it in to one or both equations to ensure it makes a true statement. Now, on the ones that we're going to do where they just give you two equations and a point, we're going to check it in both and make sure that it works. But when you're graphing, you really only need to check it in one of them to see if it works. But obviously, you can check it in both if you want. But as far as like what I'm going to require you to do, I'm only going to require you to check it in one for the graphs. So the first one, say to tell whether or not the ordered pair is a solution of the linear system. Now, I say you have to plug it into both. If I see that it's not a solution of the first equation, is there a reason to plug it into the second one? No, so I don't need to worry about that. So number 4 is the point 5,2. And they have, or the equation is 2x minus 3y equals 4, and 2x plus 8y equals 11. So I'm going to plug 5,2 in for x and y in my equations. So I've got 2 times 5 minus 3 times 2 equals 4. So that's 10 minus 6 equals 4. Is that true? Yep, 4 equals 4, so that one works. So then I need to check the other one. So I've got 2 times 5 plus 8 times 2. 2 times 5 is 10, plus 8 times 2 is 16, equals 11. Well, that's 26 equals 11. Is that true? No, so this is no solution. So if it works in both, it is a solution. If it doesn't work in both, it is not a solution. All right, so we're going to jump into it. We're going to get some more checking, obviously, as we go through problems. So we're not going to spend any more time on these right now. So these ones say to solve the linear system by graphing, check your solution. So number 12, I have y equals negative x plus 3 and y equals x plus 1. So looking back up here at my steps, it says to graph both equations on the same plane. If y isn't by itself, then obviously we need to do that. And so I'm going to look. Is y by itself in both of these?
Yeah.
Yep, so I'm good to go. So I'm going to set up my graph over here. So I've got the first line is a intercept of 3, and then I have a negative 1 slope, so that's down 1, right 1, down 1, right 1. And I would honestly put a lot more points on here than I do on a normal graph because I don't know where my intersection is, and I want to make sure that my graph isn't like looking something like this where it's kind of like not straight, because that might give me an incorrect point. So I want to make sure I'm really careful about that, or at a minimum, maybe grab a ruler so that you can make sure that you're doing a straight line as best as you can. But that's my first line. Second line is I've got a y-intercept of 1, and it's a slope of positive 1, so that's up 1, right 1, up 1, right 1. And I can already see that I've got it intersecting, so I don't need to go any farther than that, but I do need to connect, I do need to connect these. Close enough. There we go. So this point here, where they intersect, is my solution to my equation. So I need to write what that solution is as an xy coordinate pair. So it's over 1 up 2. So that means that the point is 1, 2. Okay, so that's my answer, but I need to check it and make sure it works. Again, you really only need to check it in one of them. If you want to check it in both, that's fine. But the second one has all positive numbers, so I'm going to use that one. So we've got 2 equals 1 plus 1. 1 plus 1 is 2, so 2 equals 2, so checked, done it right.
Is this all we're doing, or is it going to get harder?
Well, I mean, they're going to get harder, but this one, they pretty much set you up for success. Questions about that one before we move on to the next one? All right, 14. Y equals 2x plus 2, and y equals 4x plus 6. All right, so first line, I've got a y-intercept of 2, slope of 2. So that means up 2, right 1. And I'm also going to go down 2, back 1, just to make sure that I have, plenty of space here. Going to connect. And then I've got my next one. Has an intercept of 6. Slope of 4. So that's up 1, 2, 3, 4, and over 1. Well, that doesn't really look like it's getting any closer to my graph there, but and it's way off my graph. So I'm going to start trying to go down and back and see and the main reason I'm doing that is I don't want to make my graph any bigger than it already is. So I'm going to see. I may still have to do that, but we're going to try. So down 4, back 1, down 4, back 1, and I can already see that it intersects there. Let's see if I can actually get this connected. So this point right here where it appears that they intersect is what?
-2, -2.
-2, -2. You want to check it in the first or the second one?
First.
So I've got -2 equals 2 times -2 plus 2. It's a lot of 2's.
So that'll be -2 equals -4 plus 2. So that'll be -2 equals -2. And that's the solution.
Yep. And it works.
It's so quiet without Sean.
All right, 18. 2x minus 3y equals -1, and 5x plus 2y equals 26.
Can we do this one by ourselves?
No. I will give you one to do by yourselves in a minute, but not this one, because we haven't had one like this yet. All right, so the first thing is, obviously, I can see that y is not by itself in either equation, so I need to get it by itself. So I'm going to kind of move this one over here and do it this way. So I'm going to subtract 2x. So that means negative 3y equals negative 2x minus 1. Then I'm going to divide by negative 3. So that means y is equal to 2/3 x plus 1/3. And then I'm going to do this other one. I'm going to just work below it here. So I'm going to subtract 5x. So I've got 2y equals negative 5x plus 26. Yikes. And then I'm going to divide by 2. So y equals negative 5/2 x plus 13. So obviously this looks like it's probably going to be a relatively large graph. I would strongly encourage against you counting by anything other than ones. You will end up with the wrong answer if you don't count by ones. So we're just going to make a very, very large graph. Don't even know if that's big enough, but we're going to try. And I may still have to make it bigger going down. I don't know, but we're going to just try this and see. All right, so I'm just going to graph this one first because it's the one I can currently see on my paper or on my iPad. So I'm going to go y-intercept is 13, so I'm going to go up to 13. I think that's 13. Then I've got a slope of negative 5/2, so that means down 5, right 2. So obviously this is one I'm not going to go up and back unless I absolutely have to. And I'm going to seriously hope I don't have to go farther than this. Whoa. All right, so pretty close there. Now, my other graph is going to be a little bit more challenging. Why?
Because it's at 1/3.
Yeah, it's at 1/3, so I'm going to have to be really careful here to watch this. So that means at 1/3, I'm going to have a point. And then I'm going up to right 3. And then I'm going up to right 3. What?
Never mind, sorry.
So obviously something that's a little different about this one and the previous ones are, if you look back up here, basically all of these, they actually had a point on like the other graph, right? Like as far as like points that I was plotting with my slope, and they ended up being like, you know, I had a blue point and a red point at the same spot. Here, I technically don't, but it looks like this is probably the solution. Okay, assuming I've graphed this. Now, obviously, 1/3 is a little bit challenging, but I think that's okay. So what does this point appear to be?
Oh. 1, 2, 4, 3.
4, 3. And there's never a reason to get these wrong because I will know right away if this is right or wrong. Now, I would use the original equation to check. Why do you think I might want to use the original equation? Well, one, there's fractions, but that's not really the ultimate reason. What happens if I moved something over wrong? Am I going to know if I plug in this to over here that the whole thing might be wrong? Not necessarily. So if I use this in the original, I should know right away. So I'm just going to use the top one because the numbers are way easier. So I've got 2 times 4 minus 3 times 3 equals -1. So this is 8 minus 9. -1 equals -1. So I know that this is in fact the answer. Questions about these? So resist the temptation to count by things other than ones on these. Unless all of your numbers are like increments of 2, like on your X and your Y, then you might be okay. But I'm just saying, you need to be really, really careful with these ones. I'm going to have you try this next one on your own, and we'll see how we're doing if we need to do more after that. So 20, we have 7x plus 5y equals negative 3, and negative 9x plus y equals negative 11. So these could have fractions, they may not, but if they do, just treat them like the ones that we just did and work really, really carefully. But take a few minutes and make sure you get y by itself, and then graph them and approximate the solution and check it to see if you did it right or not. Do we have an answer yet? What do we get?
1 slash -2.
Slash. Comma?
The little line thing.
A comma?
Yeah, that thing.
Do we agree?
I'm so smart. Everybody agrees with me.
I didn't say you were right. I just asked if they agreed with you.
I'm so smart.
All right, so your two equations should have been y equals negative 7 over 5, x minus 3 over 5, and then y equals 9x minus 11. So obviously we had to kind of large graph here in the negative direction, so I plotted, and if I ever have ones with fractions, I will usually plot those second, because I can kind of eyeball where they're going to hit as we go. And so, anyways, as like an approximation. But, so I plotted the negative 11, then I went up 9, right 1, and I was like, well, I am not putting another point on here because that would make my graph really big. I'll put it on there if I need it, but I'm going to hope that I don't need to go any farther. Unfortunately, I lucked out where I did not need to go any farther. I plotted the negative 3/5, and then I went down 7, right 5, and this is one where a ruler might have been helpful. If you ever want a ruler, there's a stack of rulers over here on the, kind of on the floor. They're on top of a book on the floor over here, but you're welcome to grab one and use it if you're doing your problems. If you're like, I can see that this should be connecting, but the point's not working, whatever. The other thing I'll tell you is that I am not going to give you any, all the ones in the homework have like an even answer. So like they're going to be like whole numbers. There is one question in here that has decimal numbers. I am not going to intentionally do that. I've tried to check, or I'll try to check like quizzes and tests and make sure that they work and that there's, not a weird answer. But when you get to Algebra 2, that's not the case. But in here, I'm going to get you as close as possible to a whole number. Anyways, so just be aware of that. Are there any questions about these? Do you need to see any more? We feel okay? All right, then problems 3, 5, 13, 15, 21, and 23. So only the last 4 you're actually graphing. Do y'all want your test back?
Yes.